The question says that light incident normally on a plane mirror attached to a galvanometer coil retraces backward as shown in figure 9.29. A current in the coil produces a deflection of 3.5 degrees of the mirror. What is the displacement of the reflected spot of light on the screen placed 1.5 meter away? So when light reflects off a mirror, the angle of incidence equals the angle of reflection. Now, angular deflection by the reflected ray, if the mirror rotates by an angle theta, the reflected ray rotates by an angle of 2 theta. It gets deflected by the magnitude of 2 theta. So imagine that this solid black line is the mirror in the initial case, and this red line is the normal to this mirror, and it is reflected by and it is tilted by theta degree. Then the reflected ray, this blue line, will get deflection of 2 theta degree. Now, if we assume that this is the length between the screen and the mirror, L, then the deflection is given by small d equals L times tan of 2 theta. Now, in this case of galvanometer, theta is equals to 3.5 degree. So, 2 theta would be equal to 7 degrees. And L is given as 1.5 meter. So, substituting these values in this formula, we will get the value of deflection as 1.5 times tan of 7 degrees, which will give us 18.4 centimeter. Thank you.